Hello everyone. In this video, we are going to talk about the logic gates. Logic gates are very important as they are used in the digital electronics in the extensive way. First of all, what is logic gates? So logic gates are nothing but the electronic switch that is used to represent the arithmetic and the logic instructions or units. Okay, so what are logic gates? Logic gates are electronic switches used to represent any arithmetic and logic instruction or information. So logic gates are basically the electronic switches. Okay, these works as the electronic switches that can represent the logic and the arithmetic and logic instruction that we are going to implement or we are trying to make. Okay, so these are logic gates. So basically there are we need to know seven types of logic gates. There are seven There are seven types of logic gates that we need to know in the digital electronics. Seven types of logic gates that we need to know. The first one, the most basic one, it is called NOT gate. Okay. And second one, OR gate. Third one, AND gate. AND gate. Now, fourth one, NOR gate. Fifth one, NAND gate. Sixth one, XOR gate. And seventh one is XNOR gate. Here the first three, what we see, NOT, OR and AND. These are the basic gate. Okay. And NOR and AND. These gates are known as universal gates. Why universal gates? Because with the help of these two, NOR and NAND, we can make all the other gates. Okay, and XOR and XNOR gate. These are called special purpose gates. Special purpose gate. Okay, let us have a quick revision. So basically we are going to read about the seven types of gates: NOT gate, OR gate, AND gate, NOR gate, NAND gate, XOR gate and XNOR gate. NOT, OR, AND, these are the basic gates. NOR and AND, these are the universal gate. Why universal gate? Because the other gates can be formed using these two gates. Okay, and then XOR gate and XNOR gate. These are the special purpose gate. Now let us look into each one of it in a detail. We will we will see how this symbol looks like and what is its truth table and how it's work. Okay, so let us start. The first one, that is the not get. Not means this is also called the inversion gate or inverter. Inversion gate. Okay, inversion gate. So how does it happen? The symbol will look like this. We make a diode, right? Just the triangle and the bubble. So bubble triangle. Okay, and there is this single input here, A, and the output is represented by Y. And we output, we can say it is A bar. A bar means inverted input of A. Okay, inverted input of A. Now come to the truth table. If we make the truth table, this will look like this. Okay, this is A. Here Y is the output. Output is given as A bar. Okay, we have 0 means low. When the voltage is low or supply is low. 1 means when the voltage supply is high. Okay. So it is saying when 0 is applied here, Y will invert the not get will invert it. Means if there is 0, then we are getting 1. And 0 is for 0 we are getting 1. And if the voltage supply is high, then our output will be inverted of the high. High means then we will get A bar means 1 bar means 0. Bar represent we have to invert the input. We have to invert the input. Then 0 will become to 1 and 1 will become 0. When there is low supply, then we will get output as a high. When there is low input, when there is high input, then we will get output as a low. Okay. Now come to next. Number 2 is OR gate. OR gate. Okay. OR gate is represented as like this. This is input A, this is input B. Two inputs and this is output. Output is represented as Y. Then output will be A plus Y. Okay, A plus Y. This is the OR operation. Now come to the truth table. Truth table, we have two inputs, A and B and Y. Output, it is given as A plus B. A in digital we read as A or B. 0 0 0 1 1 0 1 1. When both the inputs are low, means 0 plus 0, then we are getting 0. When A is low and B is high, then A is low and B is high. Means 0 plus 1 means we are getting 1. When the A is high and B is low. Means A is high and B is low. We are getting 1 plus 0, again 1. A is high and B is high. When both are high means we'll get, when both are high means output will be high. Output will be high. So this is the truth table of OR, and this is the expression, the Boolean expression for OR, and this is symbol. So let us move to the next gate. Number 3, AND gate. In AND gate, we take the product. Okay. In OR gate, we were taking the summation, and in AND gate, we take the product. AND gate is represented as like this. Okay. There are again two inputs, A and this is B, and we have one output Y. This is represented as A and B. This is the AND operation. Okay. Now come to the truth table. Truth table.
Can I also? What is this?
So this is the AND gate, and let us see the truth table. For truth table, we have how many inputs? We have two inputs. So let us take two inputs here and one output, A, B. Okay, and this is our output. Output is represented as A dot B.
What is this?
This is AND gate. The symbol for AND gate, like 0 0.
What is the meaning of it?
0 1. That is the symbol.
Symbol.
Yes, and 1 1. When both the inputs are low, when this is low, means O is low, A is low, and B is low. Means we are getting what? We are getting 0 and 0. It's taking product, we are getting 0. When the A is low and B is high. When A is low and B is high, then we are, if we take like this, we will taking product, we are getting 0. Means this will also get 0. When the A is high, and the B is low, again we get the product as 0. Okay. And when A and B both are high, then we'll get the product as 1. So here 1. See. So AND gate, in AND gate we get output only when all the inputs are high. Only when there is the condition that in AND case we get the output high only when all the inputs are high. Okay. So this is our AND gate. Now let us, so we discuss all the three basic gates. Now let us move to universal gates. Universal gate number 4. Number 4 we are reading, it is called, number 4 is called NAND gate. NAND gate. And plus NOT, we get NAND gate. This is NAND. Okay, this is NAND, and this is and bubble represent the inverter. Okay, means we are inverting. This is NAND. A, B, then Y is represented as A dot B, and for this bubble we give bar. Okay, for that bubble we give bar. Now come to the truth table. Truth table we can give as A, B, Y, A dot B and bar. Okay. Again there are the 4 combination 0 0 0 1 1 0 1 1. Okay. So when A is 0, B is 0, product will be 0, but inverting we are getting 1. Fine. When A is 0, 1 is 0, product is 0, inverting we are getting 1. Fine. When A is 0, B is 0, product is 0, inverting we are getting 1. Okay. When A is 1, B is 1, product we are getting 1, but inverting we get 0. Means in NAND gate we are getting the output as 1 in all the combination except when all the inputs are high. This is just the opposite of AND gate. Okay. It is called NOR gate. This is also the universal gate. NOR gate. Okay. What is NOR gate? NOR gate we see as OR. First we make OR and one bubble. One bubble. This is our NOR gate. Here is A, here is B, and this is our output Y, and we are getting input as what? This is the OR operation, means A or B and inverter, then bar on the top. Okay. So come to the truth table. Truth table can be given as A plus B, A or B to the bar. Okay. This is our truth table. Now 0 0. 0 1 1 0 1 1 double M. Okay.
Okay.
Now 0 0 0 plus 0, we are getting output as 0, but we have to invert, so output is 1. 0 1 0 1, we will get 1 and we have to invert, then the output will be 0. 1 0, we will get 1 plus 0, that is 1, and invert it, then we are getting 0. Again 1 plus 1 is 1 and invert it, so we will get 0. So this is also, we can see this is on the output is only high when all the inputs are low. Okay. Otherwise our input will be low, and this is exactly the opposite. The truth table is exactly the opposite of OR gate. So this is also the NOR gate is also the universal gate. Now come to the next gate, that is the XOR gate. Now come to the next gate, that is XOR gate. 5 6 XOR gate. What is XOR gate? XOR gate can be given as like this. The symbol is like this. A, B, 2 inputs, and here is the output A XOR B. Baba, please open the door. This is the expression. Now truth table. Truth table is given as A, B, and this is our output A XOR B. This expression is given as A XOR A dot B bar plus A bar B. Okay. So 0 0 0 1 1 0 1 1. When A is 0, we can get from here A is 0 and B is 0, then here we will getting 1 plus A bar means 1 and B bar means 0, means 0 plus 0. So our output will be 0. Means for same we are getting 0. Now let us check for the different input. When A is 0, B bar means also 0. A bar means 1, 0 is there, A bar means 1 and then B will be 1. So here we are getting 0 plus 1, so output is 1. 1. And similarly for the second option, A is high, B bar means 0, means 1 plus A bar means 0 and B means 0. So here we are getting 1 plus 0, so 1. Fine. Now let us check for the 1 1. When A is 1 and B is 1. A is 1, B is also 1 means bar. A is 1 means 0, B is 1. Okay. So here 0 plus 0. So 0. So we are getting the output is low when the inputs are similar. And for the different input, we are getting output high. Okay. So this is the XOR gate. Now come to the XNOR gate. Number 7, XNOR gate. XNOR gate is given as like this, symbol is. This is XOR with the two inputs A and B. Okay, and if we give the bubble, we will find XNOR. Here is our output A, and XNOR is given as dot and circle, this operation, this symbol, and B. This is XNOR. This is the Boolean expression. Now this is represented as A bar B bar plus A B. Okay. Now let us see the truth table. Truth table is given as A B Y. Y is A XNOR B. Okay. 0 0 0 1 1 0 1 1. Let us see this. When both the inputs are 0, 0 0 means 1 1, and here means 1 plus 0, here 1 1. Okay. Now for the different input, A is 0 means bar, then 1, B is 1, B is 1. B bar, B is 1, then this will be bar. Now A is 0, B is 1, B is 1. So 0 plus 0, we are getting 0. 0. Fine. This is for the different input. Now the next option, when A is high, A bar means 0. Okay. B bar means 0 bar that is 1, and A is 1, B is 0. Here also we are getting 0, 0, 0. Now let us check the last one. A is 1. A is 1 bar, 1 bar 0. B is 1, 1 bar 0. Again, now without inverting, A is 1, B is 1. 0 plus 1, so we are getting 1. So here what we are seeing, when we have the same input, means A is low, B is low. A is 0, B is 0. Our output is high. A is high, B is high. A is 1, B is 1. Means our output is high. But for the different input, when A is 0, B is 1, or A is 1 or B is 0, then we are getting output as low. And this is just the opposite of XOR gate. Okay? XNOR gate is the opposite of XOR gate. So in this video we have discussed all the 7 gates along with its symbol and the Boolean expression and its truth table. So see you in the next video with some more information and the interesting topic to discuss with. Till then, bye and take care of your health. Bye.